What's up, guys? This is Matt with another video from Matt's Math Tutorials. Today we have a geometry problem that I got from a Mathletes competition that I participated in which I did not do very well, but I actually got this problem. So yeah, congratulate me on that one, I guess. So the diagram below shows two concentric circles along with four semicircular arcs. The semicircular arcs are of equal length. The area of the shaded circle is 4. What is the area of the outer largest circle? So we have two concentric circles, which means they have the same middle, right? Which is going to be this circle and this circle. Four semicircular arcs of equal length. That's all these, right? This flower shape kind of. And the area of the shaded circle, which is all this blue right here, is 4. So what's the area of this whole thing, right? That's what we're after here. So if the area of this circle is 4, we can actually find the radius of this circle, right? It's because we know that area equals pi r squared. So pi r squared in this case equals 4. So we can solve for r. R squared equals 4 over pi. Root both sides. And we have r equals root 4 over pi. Now I could like simplify this, right? Do a whole bunch of stuff, rationalize it on it or something like that. But I don't really care right now because this isn't my final answer. So I'm just going to use this because it looks pretty simple. So we know that that's the radius, which is actually going to be handily enough the distance from here to where these semicircles intersect. These are all going to be the radius. Because we know that any point on the edge of the circle to the center of the circle is the radius. That's pretty much the definition of a circle. So we have this distance. I'm going to call this R1, I guess. So that's R1, and we know that distance. So now we know this is also R1. And so now it looks like if we connect all these points, it might form a square, right? I don't have necessarily like a proof for this, to be honest with you, but I think it kind of makes sense, right? These semicircular arcs are of the same length, so it's going to form like, the same distance around each time, and there's 4 of them, so it makes sense that it would be a square. And so it seems like, right, this is going to cut this angle in half, right? This angle is being cut in half if you draw a line like that. And so it seems like if this angle to begin with is 90 degrees, that would make these both 45, right? Which means we have right here, we have a 45, 45, 90 triangle. So that should look familiar from, I think, when you first start to learn trig and you know the special right triangles. This should be one of them, I think, that you learn. And so you should learn that if this is x, then this is x root 2, right? And this is because if you Pythagorean theorem, x squared plus the other leg being the same equals, c squared, I guess. And that actually is just 2x squared equals c squared. And then root both sides. And you get x root 2 equals c, or equals just c. Yeah, so we know that this distance here is actually r1 times root 2. And so since that's a semicircle, that means that that's actually the diameter of this smaller semicircle, right? Because semicircles, you take a circle, cut it in half, cross the diameter, and then you only take one part. That's pretty much what a semicircle is, right? So if this distance right here, right, by the way, this is symmetrical on all 4 of these, so I'm just going to switch this one because it's less cluttered right now. So if we know this length, then we can actually get the radius of this. And if we know the radius of this, that would be this distance here, as well as this distance here, obviously. And if we can combine that with the distance from here to here, right, then we would have the radius of the big circle, and then we can find the area of the big circle. So now we said that the diameter of this is going to be r1 times root 2. Now what would that be? That would be root 4 over pi times root 2. So that looks like, since they're both in roots, you can actually just multiply in there. So that would actually just be root 8 over pi is the diameter of this, right? That's this whole distance, but we just want the radius. So actually we can divide that by 2, Uh, and then, so that would be root 8 over pi. If we write that as a root, then we can kind of combine them, right? Write that as root 4. And then that would be root 2 over pi, right? Because you divide that 8 by 4 and you get 2. So we know that this, well, let's call this R2. So this is R2. So now we have to find this distance right here, because if we do this distance plus R2, then we have the biggest radius, right? And that's pretty much what we want, because once we get that, we can find the area. So what's this distance? Well, same thing as here, really. This is 90 degrees, and we're cutting in half. So this actually becomes 45. We know this is 45. So this is another 45, 45, 90 triangle, except this time R1, instead of being the x here, this is actually the x root 2, right? This is actually the hypotenuse right here, this side, if we look at this triangle. So if we have R1 is root 2 times this length, then if we do R1 divided by root 2, then we will get this length right here, which will give us, right, that's the same as this length, because it's a square, and then we add that. So what's R1 divided by root 2? Well, R1 is, let's do this over here. We're doing R1 over root 2. R1 is root 4 over pi divided by root 2. This is same method as earlier, equals root 2 over pi, which funnily enough means it's actually the same as R2. Uh, I don't know if that's just coincidence or what, but it's basically, the same thing. Well, mathematically the exact same thing, although the method to get it wasn't the same. But this, let's see, what do we want to call this? New variable. Well, let's just call this, I don't know, y. Sure, why not, right? Get it? Okay, so that's y. So now we want R3, which is going to be y plus R2, right? Because we want this bigger radius, right? This thing for this, sorry, wow, that was bad. This radius right here for this entire circle, which is going to be this R2 plus this y, right? These two together. So these are actually the same thing. So we have R3 equals root 2 over pi plus another root 2 over pi, which means R3 equals 2 root 2 over pi. And I'm actually just going to put this 2 into there. So that is the same as root 2 over, that's not right, pi times root, wow, okay, I'm getting my roots and pi's mixed up, times root 4, which equals root 8 over pi. So the radius of the big circle is root 8 over pi. Now this number showed up here. I don't know, maybe that means there was a faster way to get this number, but this is how I did it during the actual time where I was solving the problem. So if there's a simpler way and I'm just not seeing it, then that's whatever. But during a contest, you have to learn that sometimes the most efficient way to do it or the best way to do it isn't what you're going to do first. But sometimes you have to just stick with what you do first, because if you get to an answer, then, it's the best way, right? That's really all you care about, is getting the answer. So if this is the radius, then we can just plug that, right, into pi r squared, pi root 8 over pi squared. Obviously, the square is going to cancel out with the square root. So we're just going to have pi times 8 over pi. And obviously, these are going to cancel, and we get just 8. Okay, we get just 8. So that means the area of this big circle is, that's an A for area, is 8. And then they didn't give me units, so I wrote units squared on my answer. I don't actually know if you have to do that if they don't give you units. Probably depends, but just want to be safe, right? So that's the answer. Now that's exactly 2 times the smaller circle. And so it really seems like there might have been a super simple way to get this answer. In fact, really, like if you were going to guess something, 8 is probably not a bad guess. But this is how I did it, and this is a pretty mathematically sound way to do it, I think. Except I don't know if you need like a proof that this is a 45, 45, 90 triangle, right? That first one that we drew, or that this is a square. But you know, you don't have to like get bogged down trying to really prove stuff, especially stuff like that that seems pretty obvious during a competition, right? You kind of want to just get to the actual math part and get an answer. So hopefully this video helped. I think in general people struggled with this problem, or at least people on my team struggle with this problem. But people always struggle with geometry because geometry is very hard in competitions. So yeah, hopefully this helped. Um, Stay tuned next week. I'll have another video. Let me know in the comments why this video sucked and what I could do better. And yeah, see you next time.